Got an example. ACL reconstructed surgery has a probability of success of 0.95, meaning the probability that we have a successful surgery equals 0.95. Now the complement rule says that the probability of a failure is equal to 1 minus the probability of success, which is 1 minus 0.95, which is 0.05. Okay? So what I want to do first is find the probability that 3 surgeries are all successful, meaning the probability of a success and a success and a success. Okay? We're going to assume that the surgeries are independent of each other, so one surgery does not affect the chance of success for another surgery. Therefore, we use the independent rule that says I multiply probability of success times probability of success times the probability of success. So this is 0.95 times 0.95 times 0.95. When I multiply this out, I get roughly 0.857. Right? Find the probability that none of the ACL surgeries are successful. That means that I have a probability of a failure and a failure, and a failure. Now they're all independent, so that's probability of fail, probability of fail, probability of fail. Now the probability of failure is 0.05. And if I do that 3 times, if I have 3 failures, what's the chance of that happening? Type that in your calculator, you get 0.000125. Okay. Now, this one here, find the probability at least one of the surgeries is successful. So that means I have a probability, and now at least one means you could have 1 success, you could have 2 successes, or you could have 3 successes, right? So probability of success, probability of success, probability of success. Okay. You could also have probability of success and success and a failure, but you could also have probability of success, failure, and failure. Okay, at least 1 success going on there out of 3 surgeries. Now we already found this one. This probability of success times probability of success times probability of success. That was 0.857. Okay, this one, probability of success times probability of success times probability of failure is 0.095 times 0.95 times 0.05. And if I do this in my calculator, I get 0.95 times 0.95 times 0.05 gets me 0.45125. 0.45125. Okay? And let me make sure that was right. Oh, yeah. All right. And then this one here, probability of success times probability of failure times probability of failure is 0.95 times 0.05 times 0.05. So it's 0.95 times 0.05 times 0.05. That's 2375. 0.02375. 002375. Okay. So 2 zeros and then 2375. All right, now we've got ourselves a problem, because if I have a success on the first one, but then I have 2 failures, that's a different scenario than having a failure on the first one, a success on the second one, and then a failure on the last one. Okay? So we could also have a scenario where we had 2 failures first, and then we have a success. And all of these would represent the one success scenario. So we have this 0.002375 3 times. Okay? Now there's only one way to get 3 successes, and that's what that probability is here. But this one, I can have two successes. I can rearrange this another way as well. How so? Well, I could have probability of success and then a probability of failure and a probability of success here. But I could also have probability of failure, probability of success, and a probability of success. And I think that would be all the different scenarios there. And so that 0.045125 here, that 0.045125 here. So I need to add up all these probabilities. And if I add up all those, that's like saying 0.857 plus, and how many of these are there? There's 0.045125 three times. And then there's 0.002375 three times. And if I add all those up, so 0.857, all right, clear. 0.857, or 875, sorry. It is 857. All right, go back. 857 plus 3 times 0.045. 045125 plus 3 times 0.002375, enter, and that's 0.9995. Okay, 0.9995 seems pretty small. All right, so that's the 3 different ways for at least one. So there's 1, 2, 3, 4, 5, 6, 7 going on there. Now, there is one other possibility that can happen, okay? And the only one that we didn't list was the probability of fail, and that's 3 failures. So this is the complement rule. This is where the complement rule can help you out, okay? So how does the complement rule help you out? The probability of at least one success is equal to 1 minus the probability. Well, what is the opposite of at least one success? The opposite, the complement, is no successes. Okay? No successes is 3 failures, which we found to be 1, and then minus 0.000125. And if you do this into your calculator, guess what? That's going to give you 0.999875. Okay, 0.999875. So, what's easier? To go through here and do all this stuff right here, or to use the complement rule effectively? Personally, to me, I think the complement rule is the way to go. All right, but that's up to you. So in this problem, we have a jury. 65% of people are female. Of the 65%, 1 out of 4, or 25%, work in the health field. Okay, so that's of the 65% that are female. So if I want to find the probability of randomly selecting a person from the jury pool is female and works in the health field. So I want you to label. So we need a label. So selecting a person that is female, I'm going to call that event F. And working in the health field, I'm going to call that event H. Okay? So find the probability that we're female and work in the health field, this is equal to the probability that you're female times the probability that you're working the health field given you're female. This is equal to, what's the probability you're female? It's 65%. What's the probability that you work in the health field given that you're female? It's 1 out of 4. Multiply this together, it's roughly 0.163. The next one, find the probability that a person is female and does not work in the health field. So this is complement of H, does not work in the health field. Okay, that's a complement of H. So the probability that you're female and you don't work in the health field is a probability that you're female times probability that you're not in the health field given you're female. Well, female is still 0.65, but to be the opposite of not in the health field, what is the opposite here? The complement of 1/4 is 1 minus 1/4, which is 3/4, 75%. So 3/4 here. And so if I multiply that out, I get 0.488.